It's about 10 or 11 at night, and we're connecting the camera system. Countless plugs, one after another, and let's hope everything works out tomorrow. This is a complex system. I'm in the midst of it. This is, after all, highly experimental.
Yeah, bridge, rope us on the back deck. How do you copy?
Big bridge, clear to launch on my side.
Coming up, guys! Okay, going down slow. I'll stop, Mike. All clear for sub motor.
Sub motor out of bypass.
Quarter ahead.
Quarter ahead.
Every trip is different. There's different challenges. Getting new equipment put on, getting it working, and dealing with new people is always, it keeps it interesting. It's always fun.
Yes, it is especially difficult. One, we've never been here before, so it's like driving into a new town somewhere. We're completely lost, so the streets aren't familiar, so we're not sure what's more than 25 meters in front of the vehicle, other than what our sensors are telling us. All the sensors on the vehicle are exposed in the back, so we're flying around big rocks and thermal vents, and we have the dynamics of the ship and the cable to manage, so it's a challenge to stay on top of all those.
Black smokers are formed by seawater which percolates down into the hot oceanic crust, is heated to temperatures of 350, 400 degrees. It dissolves metals from the rocks and brings them back to the surface, or at least the seafloor, where they form the black smoker vents. This particular area is unique in the sense that we have two converging plates. One plate being subducted under another plate, which is bringing great quantities of metals and volatiles to the volcanic area, and those are brought to the surface here not just by circulation of hydrothermal seawater, but also by volcanic activity and actual degassing of magma. I'm paying particular attention to where the hydrothermal venting occurs relative to the structure of the volcano. All volcanoes have structure. They have centers, they have outer perimeters, they have carapaces, they have dikes that cut through them, faults that cut through them, and all of those structural features of volcanoes control where the hydrothermal fluids go. But we're not very good at predicting that, and we map, which is what I'm doing, we map those structures in order to identify what's controlling where the hydrothermal fluids go. They have high concentrations of metals like copper and zinc and silver and gold, and these in particular in the area of Tonga and the Western Pacific have very high concentrations of copper and gold, and that has a certain value that is of interest to some mining companies who may ultimately develop and exploit these deposits for those metals.
I'm looking for anything that moves or might move. So I'm particularly interested in the animals on the seafloor, the benthic animals. Most of them don't have a backbone, so we're looking at things like the snails. There are at least 2 species of snails with different colour morphs that I'm trying to locate and log. Looking at all the crabs. In some cases there might be some mussels, but we'll need to get a bit closer to the seabed to confirm that. Lots of shrimp. There are some things called scale worms that are quite funky. That's probably the main organisms I've been logging. I think if I was a shrimp, I'd probably be freaking out just a little bit having something so bright, considering they live in complete and utter darkness. But they don't seem to be bothered by the research that we do. They're not swimming away, they're not changing, as far as we know, their natural behavioural patterns. And they have done research studies to see the effect of light on shrimp over time, and it looks like we don't cause them any harm, which is good news.
We've developed this system for the better part of 2 years, and it is a joy to see everything working. Everything works. We have not let anything down.
We want to try out several things on this cruise. So we have a number of different cameras here. We have the highly sensitive video camera. We have the photo camera that takes high resolution stills. And we have also a stereo camera system. This is a collaboration with Anne Jord from Geomar. The goal is to use stereo reconstruction jointly with a multi-beam echo sounder. And the principle behind the stereo camera is that we have 2 different perspectives onto the objects that we see underwater, as with the human eyes. And from these different perspectives, we can reconstruct the 3D position information of the things that we see. And by using the navigation data from the robot, we can then build up a 3-dimensional point cloud, which represents the seafloor. At a later stage, we want to put this into a geological, biological, or geochemical context and make big models out of this and do interpretations of this.
Right now we are doing what we call mowing the lawn, which is surveys back and forth to photograph as much coverage of the seafloor in the crater as possible. The pilots are following predetermined survey lines, but the topography here is so variable because of all the chimneys that it's somewhat slow going, because we want to maintain a certain height above the seafloor so that we can illuminate the seafloor with the flashes for the topography, but we also have to fly up over these chimneys which we're coming across, which can be up to 10 or 12 meters high sometimes.
And the work we're doing now, while it can seem tedious because you're driving lines and mowing the grass, so to speak, on the seafloor, it's actually quite difficult because you're watching about 10 different things at the same time. So it can be moments of tedium interrupted by moments of sheer terror as you're just about to crash into something.
RV bridge.
Yeah, that's Robos moving off on the next line to the northwest.
Okay, thank you very much. Just for your information, I'll probably move ahead about 40 degrees to starboard to follow you on that next line.
Roger, roger. Robos on the move. Here we go.
My expertise is structured light, so we use a laser line which is projected onto the seabed, and then with a camera that is capturing these laser lines, we can estimate the depth of the seabed in respect to the camera. Depending on the height, the laser line is at a different position in the camera image, and with that information and navigation information from the vehicle, we are able to do a full 3D reconstruction of the seabed in very high resolution.
We haven't seen the results of this, but it's very exciting to be able to, in the end, visualize what we've built here, because it's a lot of money and a lot of work and a huge effort by all these people to put this together. So I'm really looking forward to seeing the results of this walkthrough of the subsea volcanic crater.
Well, I still think it's amazing, and maybe because I'm new to all this, but I think it's incredible that we can go to these areas that no one's been to before and still discover things. We've been doing science for hundreds of years, and to still have that essence of discovery is amazing. And to be some of the first people, maybe even some of the only people, to ever see these environments and these animals, and to be the first people to shine a light on something, I mean, I think it's incredible.